In this example, we'll be identifying equivalent equations. Before we identify equivalent equations, we have to understand what equivalent equations are. And those are equations that have the same solution. So what I mean by that is I'm going to start with a very basic set of equations here, and I'm just going to go 2x equals 10, and then x plus 5 equals 10. So we have two equations here. And the solution for our first one, 2 times what gives us 10 is what we're trying to find. Well, we know that x equals 5. 2 times 5 would give us 10. For our second one, it's x plus 5 equals 10. So what plus 5 gives us 10? And again, we should know that x is going to be equal to 5. So because we have the same solution here of x equals 5, that means that these two equations are equal to each other. 2x equaling 10 is equivalent to x plus 5 equaling 10. Now in our first example problem, we have the two equations. We have x plus 3 plus 6x equals 13. And then we have 7x plus 3 equals 13. The first method we're going to look at to see if equations are equal here, we're going to look at both sides of the equal sign. You'll notice on both sides, on the right side of the equal sign, we have a number of 13. So both right sides are 13. So I don't have to change anything on the right side. I'm going to look and focus on the left sides now. This one down here, 7x plus 3, that's simplified. I cannot do anything else here, so I'm stuck with 7x plus 3 in that one. Up top, though, we have x plus 3 plus 6x. If I combine my x and my 6x, that gives me 7x plus 3 equals 13. And what we should notice here is they are the exact same equations, therefore they are equivalent equations. In this method here, we didn't have to figure out what the value of x was. We didn't have to solve for x. We just simplified both sides of the equation because we saw that one side was already the same. If the left side ended up being the same, then that means they're the exact same equation. In our next example, we have two equations here. We have 5x minus 4 equals 6. And then we have 5x equals 20. For this method now, I notice that the right side of my equation, 6 and 20, are not the same. So simplifying both sides, or simplifying the left side, is not going to work out for me. So what I'm going to try to do here is I want to solve for x. So I'm going to take the equation that I think is easier. I'm going to choose this one over here because I think that 5x equaling 20 is a little easier to solve than this 5x minus 4 equaling 6. I know that 5 times 4 gives me 20, which means that x is 4. So in this problem here, x would have to equal 4. If x equals 4 for this equation, that means that we have a set of equivalent equations. So what I'm going to do now is substitute, and I'll plug in the 4 for x, and we have 5 times 4 gives us 20. 20 minus 4 has to equal 6. 20 minus 4 equals 16. So 16 does not equal 6. Therefore, these two are not equivalent equations. They do not have the same solution. This one was x equals 4. This one over here, we don't know what that was. We could figure it out if we wanted to, and it would actually be x equals 2. Another method we could use, it's kind of like our last example for part B. This one here, we're given x equals 6. So we're given that x equals 6 in one of those. So my two equations here are 2/3 x equals 4 and x equals 6. And we're trying to determine if these two are the same, meaning they have the same solution. Well, we already know the solution here is x equals 6. We already know what x is. So what we could do is substitute on the equation on the left. So I'm going to set it up as 2/3 times 6, and that should equal 4 for these two equations to be equal to each other. 6 times 2 gives me 12 over 3. 12 over 3 equals 4, so we're left with 4 equals 4. So because this is a true statement when we plugged in for the x, when x was 6, this made this true. That means that these two are equal equations. Those are equivalent equations because they had the same solution of 6.